All right, we're live with Sixth Period. Say hi, Sixth Period.
What's happening?
All right, so we're going to start going over some of the things that you're going to need to know for the final exam. So I'm going to start off with question 1. First of all, it says, which of the following indicates that the events A and B are independent? This question right here comes directly from the formula sheet. And it's also, we know that according to the district blueprint, you're going to have one question that relates to this topic. When it says independent, there's 2 things that you can look for. First, if it's like how it is here, P, where it says A and B, you know you're going to use the formula sheet. If instead it says like something like the probability of A given the probability of B, then it's going to be independent if these 2 are equal. But in this case, because none of the answer choices have given in it, I know I'm just going to be multiplying. So the first one, if I have 0.1 times 0.2, that's going to end up giving me 0.02, which is not correct. Then if I do 0.68 times 0.42, that's going to give me 0.2856, which even though it's very close to 0.26 is still not correct. If I have 0.64 times 0.32, that's going to give me 0.2048, which is not correct. And then finally, when I multiply these together, I get 0.56, which is the correct choice. Recording a video right here. So, next, consider the events A and B, the probability of A and the probability of B, okay? Now here it gives you, tells you what's the value of probability of A given B, okay? Because we have this, we know it says the probability of A given B. Well, whatever B is, that's always going to be in the denominator. So we know that the probability of B has to go in the denominator. Whatever they have in common is what goes on top. And we know that from the formula sheet. Now, if they had asked you what's the probability of B given A will end up being in the denominator. So you have to pay attention to what they're asking you. In this case, because it says A and B, B is the one that goes in the denominator. So I know that I'm going to take 0.12 and I'm going to divide it by my B value, which is 0.35, which means in this case, they gave you extra information that you didn't need. The reason why you didn't need that extra information is because they're trying to confuse you. You have to pay attention to what the letters say. So now I'm just going to type that into the calculator. And I get 0.042, which is not correct. What did I miss? Oh, because I hit times. Thank you. 0.34. Okay. Next. A randomly selected group of people of varying ages was asked whether, thank you for correcting me, was asked whether or not they usually remember their dreams. The results of the survey are shown below. What's missing from this table? Total. So I don't know if we need it, but we have to think. If it doesn't say total, we might have to do that addition on our own. So suppose one person is surveyed. Are the events, the person is 50 or older, and the person doesn't usually remember their dreams, independent or dependent. So I'm just going to label a person is 50 years older as A. So that means that this column will be my A. And I'm going to label a person doesn't remember their dreams as B. And so these are the only 2 pieces of information I care about here. Now, because it says independent, there's 2 things we look at. We look at given, and if it's given, we do what we did on the last slide, or we have to look at the formula. So basically what we're going to do is the probability a person is 50 or older. Well, how many total people are 50 or older? Well, we need to know how many total people there are altogether. So first, we do have to figure out the totals. So I've got 12 plus 18 plus 14 plus 20. That gave us 64 here. $10, $20, $30, $46, $46, $26, $52, $72. So we have 136 people altogether. Oh, actually, we don't even have to figure anything out. Yep, it is C. Man, here I'm trying to do all this math for no reason. Good catch. So remember how I told you before that the probability, if the probability of A given B equals the probability of A by itself, then we know it's independent. I should have looked at the answer choices first. That was my bad. Next. In a survey, 36, stop. If in a survey of 36% of people state that they enjoy outdoor activities, 25% state they own a pickup truck, and 9 state they enjoy outdoor activities and own a pickup truck. So first, we're going to have to turn these into decimals. We've got 0.36, 0.25, and 0.09. It wants to know if they're independent. Remember, the formula for independent is either, guys, that's my instruction, is either taking the probabilities and multiplying them or the given one. So in this case, we know we have to multiply, so we're going to cross out A and B right away. Then we're going to multiply it. Well, what's 0.36 times 0.25? 0.09. So because it's equal, it's going to be choice C. No, it's 30-30. And earlier I said no because it was plenty of time where we weren't working and then someone asked to go. I don't care. So next, number 5, a survey of, someone else asked earlier and I said no to them. I'm explaining why. A survey of 10,000 randomly selected students generated the following data on the grade level and preference for pens and pencils. So now in this case, we do have the totals. So now we have to figure out what each of the things mean. Is it much less likely for a 10th grader to prefer pencils than for a student to prefer pencils to be in 10th grade? Oh, that's interesting. So because for a 10th grade student, so 10th grade student is going to be our given. So there's 5,171 10th grade students. To prefer pencils, how many of them preferred pencils? Well, 1,115.
You said pencils.
Oh my gosh, I did.
So it's
4,056. It is all over the place. I'm trying to think about why people are still being silly right now when they shouldn't be. Good catch, Tati. And then, so that's compared to a student who prefers pencils to be in 10th grade. So that means how many people prefer pencils? 7,880. And how many of them are in 10th grade? This number. So see how this is much less likely? Well, we know right away, comparing the numerators, this is bigger. So it can't be choice A. You also could find the decimals if you wanted. 4056 divided by 5171. That equals 78%. Yep.
Okay, so you know how it says, when it says 10th grade students prefer, when it says that we go to the
Of the 10th grade. So in this case, this is, yep. So this is bigger than this one. We know it's not A. So then we got to do the same thing again for B. So B says it's much more likely for an 11th grade student, so that's going to be our given, 4,829, to prefer pens, 1,005, than it is for a student who prefers pens to be in 11th grade. And then it says it's more likely, so we're trying to think this one's bigger than the other one. So right away, just estimating, this is going to be about 25%. And this is going to be about 50%, so this is wrong. Next. It's less likely for a 10th grade student to prefer pens. So there's 5,171 10th graders who prefer pens. And it says it's less likely than a student that prefers pens, 2,120, to be in 10th grade. And in this case, that's correct. So it's choice C. Because 1,115 divided by 5,171, this gives you 21.5%. 1,115 divided by 2,120, that gives you 52.9% or 0.6%. So that's true. So because that's true, it's choice C. That was really hard. Okay. Next, question 4. In a shipment of 8 small motors, 2 are known to be defective. Suppose that one motor is removed from the shipment and found to be defective. If another motor is randomly selected, what is the probability is working correctly? So we know right away there's 8 motors. We know 2 of them are defective. So that means that 2 out of 8. Now they tell you that they took one of them out. So because they took one of them out, I'm going to cancel. Like that's what I said. We're gonna cross that one out. So then we have to see how many are left. So now we look here. Well, because you took one out, altogether there's 7 left and 1 of them are defective, which is not one of the answers. Oh, it's working correctly. Sugar shoots. I know. 6 divided by 7. Thankfully, they didn't give us that as a distractor. 85 point. There we go. D. My bad. I own that one. 7. The following table shows the results of a survey where high school students were asked to estimate the amount of time they spend using social media each week. Well, we know this. Oh, this is more accurate. What is the probability that a randomly selected student from this group is a junior or, remember I told you or, so we have to add and then we have to subtract. Anytime you see or, you add and subtract. So it says, is a junior, that's going to be my total group. How many people are juniors? And then how many spend 5 to 9 hours a week? This is my B. And then I'm going to have to subtract this overlap. Oh, wrong overlap. So here's my juniors. Here's my B. And then I have to subtract this piece that's the overlap. So I've got, altogether there are 459 juniors over 1,800 people. I'm going to add 646 people who spend 5 to 9 hours a week out of 1,800. And then I have to subtract, you know that's not true, those extra. So typically when I do OR problems, because in order for it to be OR, the totals are always going to be the same, I typically don't even pay attention to the denominators. I'm just going to do the numerators first. 459 plus 646 minus 184. I get 921. Divide that by the 1,800, and you're going to get 51.2. Okay. I don't know. Talk to Sean. You found some. Next. Christian, maybe you can just. Okay. Next, page 5, number question 8. A doctor's office surveyed patients. Remember, there's going to be one question about Venn diagrams. A doctor's office surveyed patients about their eating and exercise habits. The responses are represented in the Venn diagram below. So you've got 42 people only eat healthy, 17 people only exercise regularly, 78 do both, 63 do neither. If a surveyed patient is selected at random, what is the probability that the patient reported eating healthy or exercising regularly. Now, in this case, it's it's a little bit different than the formula, because most times, most of you will just add these three up, which is the correct way to do it. So all we're going to do is 42 plus 78 plus 17, and we have to divide that by the total number of people. And we get that by adding all these numbers up. Technically speaking, the correct way would be to figure out how many total people are here, how many total people are in this category, and then subtract the overlap. But for Venn diagrams, usually it's easier just to add the appropriate numbers up. Let's see, 42 plus 78 plus 17 gives you 137, plus 63 should give you 200. So when we divide, we're going to get B. I divided by the total number of people that I got from adding all the sections and the 63 people who don't eat healthy or exercise regularly. Question 9. The equations, finally we get to get off probability. The equations of circles S and T are shown below. Here it says all circles are similar. So how can we know that things are similar? A rotation of 180 degrees, followed by a dilation. Hold on. Oh, takes S. All right, I missed it. Takes S to T and thereby establishes that they're similar. Okay, so the center of S is -15, +20, and our radius is 9. Hi, stop. T, our center is +8, -12, and our radius is 5. So we already know if it's going S to T, we know that we're going from new over old. So I'm going to take my T divided by S. So my T is 5. My S is 9. So that's my scale factor, which unfortunately every single one of these has that scale factor. Now we have to figure out, how does S move to T? So a rotation of 180 degrees, all that will do is flip. All that will do is flip the coordinates. So it's not going to be letter A. Then it says reflecting over y equals x. Again, that just flips the coordinates. So that's not going to be that one. The next one is 23 units to the right, which means adding. So let's see if that works. -15 plus 23 is 8. So that's true. 32 units down, that is also true. So it's choice C. It has been C. And then here's the thing that's bizarre is here they give you 23 and 32. So it's testing you if you're reading right, left, up, down. Okay. Number 7, page 7, question 10. Here we've got these points, Q, R, S, T. They're consecutive on the circle. Which angle must be congruent to QST? Well, look at QST. If we fill in this ice cream cone, now we have to just fill in the other ice cream cone that shares the same arc. So that's QRT. So A for Anne Marie. There you go. Instead of C for Christian. Here we go. Next one. And okay, this one, you guys, I think you saw this on the strategies test. It was one of the questions someone said. When you have this, an inscribed quadrilateral below, it says 2 angles are given. What's the measure? Remember that opposite angles are going to be supplementary. So we've got x plus 102 equals 180. So x has to be 72. Oh, sugar shoots, 8. So it has to be choice A. And then obviously x plus 8 or y plus 80. Hi. Hi. Thank you, Vaughn. So, recording video live right here. Line segments. This we're going to read this and then go to the question. It says the line segments A, B, C, D are diameters. So that helps us because first of all, we know these are vertical angles, and then we know because they're diameters, we can subtract from 180. So it says if the circle has a circumference of 10, what is the arc length of BC? So the circumference has the 10 pi or just 10? Nope, just 10. So if the circumference is 10, it wants to know arc length of BC. This is what I told you earlier today on the circumferences that we need to make sure that we substitute. So we're going to put in 10 equals pi d. And this first will give us the diameter. So if you do 10 divided by pi, you're going to get 3.18 as the diameter. But the arc length formula is 2 pi times the radius times theta divided by 360. So now we have to figure out what the radius is. So we do that by taking 3.18 and dividing that by 2. That gives me a radius of 1.59. So now I can use that information in my formula. So I've got 2 times pi times my radius, which is 1.59, times my angle that someone said was 144, that's correct, all divided by 360. Now, I'm not going to confuse you, never mind. 2 times pi, tell me about it, times 1.59 times 144 divided by 360 gives you 3.99, so we can round that to 4. Now, technically speaking, the whole formula for arc length is really you just take the circumference, you multiply it by theta, and you divide it by 360. So because they gave you 10 to begin with, you could have just done 10 times 144 and then divided everything by 360. That would have been the easier way. We're going to